This is audio lecture part 3 for chapter 6 and 7, reliability and validity and criterion reference tests. So in parts 1 and 2 of our audio lectures, we've talked a lot about reliability and validity. Now we're going to switch gears to different types of evaluation. We have 2 common ways to interpret and evaluate the meaning of a test score. Those are norm-referenced and criterion-referenced evaluations. We're going to break those down going forward. As we've discussed previously, norm-referenced is a person's score compared to peers. Sometimes norm-referenced is abbreviated as NR. So now we're looking at that evaluation component. So a norm-referenced evaluation is a relative classification. This is when the score is often compared to a previously developed norm. We want to use this when we want to determine a person's rank or position within a population. This is common in human performance, but some other things that we've used norm referenced for is anytime we're comparing anything with a percentile or anything like that. So some other examples of norm referenced tests are things like IQ tests or SAT tests. Again, anything where we're kind of looking at that percentage ranking or percentile ranking. While norm-referenced evaluation is common, there are some limitations of it. Many norms we used in human performance are outdated, and it's really difficult to update them because of cost and time. The referenced population has to be quote-unquote normal or healthy. And norm-referenced evaluations tend to reward the top group and disadvantage the lower group. So we need to take note of some of these limitations when we're utilizing norm-referenced data. This graph is figure 7.1 in your book. As you can see here, this is a norm-referenced evaluation. It follows our normal curve, and that's because the data that it's based on has been normalized. So here you can see our mean is 0. We have our standard deviations. They have our normal distribution. So between 0 and 1 standard deviation is 34.13%. And then if you look below, you can see your percentile equivalents. So 50% is right in the middle at our 0. And then we can see when we get to 1 standard deviation on the positive side, 80% of the scores are from that positive 1 to the left. And then you can see it goes all the way up to 99, which is about 3 standard deviations. If you look on the percentiles on the left-hand side, we can see that at negative 2 standard deviations, only from there to the left only contains 5% of the data, and so on. So again, that norm referenced, we have a large database that is then normalized and then converted to this normal distribution. On the other end, we have criterion referenced evaluations. So these tests take the performance and it's compared to a predetermined absolute criterion behavior. So previously we used the example of a driving test. There's a predetermined behavior. When you're driving on the road, if you hit a curb, you automatically fail, or you need X amount of points in order to get your driver's license. A test based on criterion evaluation is known as a criterion reference test. This is often abbreviated as CRT. These performance standards are generally specified by defining a class or domain of tasks that should be performed by each participant. So a fitness example would be a PACER test. Prior to taking the PACER test, you need to hit X level in order to get an A, and this level to get a B. It's an absolute value. It doesn't matter how anybody else scores. You have to meet that threshold in order to get the associated grade. Regarding criterion referenced evaluations, we need to set a valid absolute cut score or a standard, and that can be really challenging. It must be connected with the construct that's being measured and support the classification made. It should also be able to stand alone and be consistent with any individual from the targeted population. The consequences of the decision based on standard criterion evaluations can be really serious. For example, you need a minimum score on a written driver's test, but if the cut score is too lax, people might be driving that don't know enough of the rules of the road to be able to drive safely. So you need to make sure that whatever that cut score is rigorous enough to weed out the people that shouldn't be qualified, but not so rigorous that we're weeding out people that are capable. Within our criterion referenced evaluation, we have two kinds of errors that are possible. We can have a false positive or a false negative. For a false positive, that's when non-masters are classified as masters. For a false negative, masters are being classified as non-masters. So if we talk about that written driving test again, if we look at, let's say the cut score is too lax, then we're having people that don't know enough of the rules of the road that are being classified as knowing the rules of the road. A false negative is if the test in that situation was a little too rigorous. People that do know enough of the rules of the road to drive are being classified as non-masters, so they're not able to pass or get their driver's license. This is figure 7.1 in your book. Previously, I had showed you the top half of this image, the norm referenced evaluation. Now we're focusing on the criterion referenced evaluation, or the bottom half. As you can see here, there's two different curves being plotted on the same graph. The curve on the left is our non-mastery expected curve, and the curve on our right is the mastery expected curve. So if we look here, the yellow highlighted part is everything under the curve of our mastery expected participants. So what this means is everybody, if we continue to use the driving test or the written test for your license as an example, everybody that has the requisite knowledge that's necessary to drive would fall in this yellow area. This green highlighted section is our non-mastery expected. So those that don't have the knowledge necessary to safely drive would fall under this green area. However, we talked about us needing to have some sort of cutoff score to determine if they can actually get a driver's license or not. So that's represented here. This is our cutoff score. The arbitrary predetermined value that they have to get on the test in order to get their driver's license. So this highlighted part in orange, these are our false negatives. So we expect they have the requisite knowledge to safely drive, should be able to get their driver's license, but they didn't meet the appropriate score. So they scored below the threshold, but they do have that knowledge. That's what we call a false negative. This is where a master is classified as a non-master. On the contrary, this blue highlighted part are people that don't have the requisite knowledge to safely drive a car, but somehow they scored above that threshold, above that cutoff score. So they're considered mastery, okay? That's what we call a false positive. So a false positive is where non-masters are classified as masters. This is bad because it means if we continue to use the driver's license, these people shouldn't be driving because they can't do it safely. They don't have the appropriate knowledge to do it. Whereas if we go back, our false negative is still bad, but it's less bad, right? It's not quite as critical for a master to be considered a non-master as it is for a non-master to be considered a master. So when we're using criterion referenced evaluation, it's used to make categorical decisions, such as pass-fail, or meeting the standard, or not meeting the standard. The cut scores are usually a minimum score to demonstrate competency. They typically involve nominal data, however, they may involve continuous data as well. Criterion reference tests involving continuous data use cut scores to separate participants into categories, such as pass or fail. Remember that nominal data is just categorical, such as grade level or gender, versus continuous data is on a number line, something like shoe size or height or weight or test score. So when we're setting criterion reference standards, there's 4 different approaches. We're going to talk about 2 of them here and then 2 of them on the next slide. So the first approach is the judgmental approach. This is based on the beliefs or experience of experts. For example, a coach decides you need to be able to serve overhand to make the volleyball team. They decide to make a cut score of 8 out of 10 to make the team. You have to make 8 serves out of the 10 over the net in order to make the team. The coach in this example is the expert, and they're the ones that determined the cut score. The second approach is the normative approach. This uses norm reference data to help set standards with a theoretically accepted criterion. For example, you can use the expert opinion. So a cutoff score during a functional movement screen assessment, there's a cutoff score that determines increased injury risk. So they had a bunch of people do this assessment, put all of the data into a spreadsheet, analyzed it, and they saw that if you got a score below, let's say 34, you had an increased risk of injury. So that's using that normative approach. So using all of that previous norm reference data to help set the standard or set the cut score. The other 2 approaches are the empirical approach or the combination approach. In the empirical approach, it uses an external criterion measure. This is the least arbitrary, but it's seldomly used because of a directly measurable external criteria. For example, a firefighter having to scale a 5-foot wall is necessary to perform their job duties. So that's the criteria in order to become one of the criteria in order to become a firefighter. If you can't do it, you can't perform your job duties, so you can't pass the test. Or there's the combination approach, which involves the use of multiple available sources, things like experts, prior experience, empirical data, or norms. There are a lot of advantages to using criterion referenced evaluations or tests. One is that criterion reference standards represent specific desired performance levels that are explicitly linked to a criterion. This could be a health outcome. The standards are absolute, so they are independent of the proportion of the population that meets the standard. Meaning, regardless of how many people smoke, the goal is always to lower the number. We always want fewer people to smoke. Also, it has specific diagnostic evaluations that can be made to improve performance to the criterion level. So if someone doesn't meet the standard, let's say, of 150 minutes of physical activity a week, we can give feedback on what to do so that they can meet that standard. Additional advantages are that the achievement is based on reaching the standard, not doing better than someone else. So it doesn't matter how somebody else did. It's important that you're trying to improve to meet a specific threshold. The performance is linked to specific outcomes, and the participants know exactly what's expected of them. They know exactly how many push-ups they're supposed to do or get to, or exactly how quickly they're supposed to run a mile. It's achievable. While there are a lot of advantages, there are still some limitations of criterion referenced evaluation. The first is that cut scores always involve some sort of subjective judgment. We can try to make them as objective as possible, but there's always some subjectivity. The consequences of that misclassification can be severe. I'm talking specifically when we classify non-masters as masters, and participants who attain the cut scores may not be motivated to continue to improve. So on the push-up test, if you've already met the cut score goal, you don't necessarily have motivation to continue to be able to do more push-ups. When we're looking at the statistical analysis of criterion reference tests, we need to first categorize the data into nominal variables. So it needs to be some sort of categorical in nature. It's usually above or below the norm or the standard. For these, the primary tool for analysis is a statistical technique using a contingency table, which is also called a 2x2 chi-square. So what a chi-square is, it's a test of association between nominally scaled variables. The criterion referenced test, stability reliability, which is an association between how a person does on the first and second attempts of that criterion reference test. And then we also have criterion related validity, which is an association between how a person does on a field test and on the criterion test. We're not going to talk a lot about chi-squareds. It's just something I want you to be aware of. This is the conclusion of part 3 of the audio lecture.